Okay, so now we're moving on to the method of elimination to solve for systems of equations. And the first thing we're going to do to eliminate or to get rid of one of the variables is add the two equations together. So what happens whenever we do this is we got x plus y equals 4 and 2x minus y equals 8. So we can see we have the y's that are the same coefficient in front, they both have a 1 in front, and they're opposite signs. So I have a positive 1y and a negative 1y. Now I can get rid of that variable y very easily by adding these two equations together. So what I'm going to say is I'm going to add these two things together. And what's going to happen whenever I do that is 1y plus a negative 1y means that's going to be eliminated, and those are going to cancel out. Then I got 1x plus 2x is a 3x, and 4 plus 8 equals 12. Now I have one step to solve for my variable x and get that value. So whenever I divide by 3, I get x equals 4. Now we got one more step to do and find out the value of y. So we're going to do that the same way we did before and plug that value into one of these two original equations. So I'm going to do the top one right here because that one is easier, the numbers are smaller. So I'm going to say 4 instead of x, 4 plus y equals 4. Now to get y alone, I'm going to subtract 4 from both sides and say y equals 0. Okay, so there are my two answers. There's my solution to that problem. So whenever I write this as an ordered pair, I'm going to say 4, comma, that's pretty bad. Let me redo that. 4, comma, 0 as my answer right there. Now remember, I can plug in and make sure that works out and that's correct in the solution. So I can put in here 4 for x and 0 for y and say 4 plus 0 is 4, that works. 2 times 4 is 8, 8 minus 0 is 8, so that works. So the solution for 0 is it, that works. Another example here, I got negative x plus y equals 4 and x plus 3y equals negative 12. So this time I have the opposite things, the opposite front signs, and the same number in front of the x's. It happens to be a 1 again. So whenever I add these two equations, the thing that's going to go away this time or be eliminated is the x because they have opposite signs and the same coefficient in front. This is a negative 1x and this is a positive 1x. So I can say, whenever I add, that cancels or that eliminates. And 1y plus 3y equals 4y. And 4 plus a negative 12 is a negative 8. Now I got one step to solve for y, divided by 4. So I get y equals a negative 2. Okay. Now this time, remember what I'm plugging in for is y, because that's the value I found first. And again, I'm going to plug into that top equation that says negative x plus y equals 4 because that has some smaller numbers in there. So I'm going to say negative x, and then instead of plus y, I'm going to say a minus 2, because that's what y is in minus 2 or negative 2 equals 4. Okay, now this time I have two steps to solve, so I'm going to add 2 to both sides. So it's gone there, and I got negative x equals 6. Then to get rid of that negative in front of the x, I got to divide by a negative 1, and I get x equals a negative 6. So my solution this time's negative 6, because the x has to come first, negative 6, comma, negative 2. So that's how I'm going to write it, is negative 6, negative 2. And if I want to check, I can check in my original equation. So I can say negative 1 times a negative 6 is 6. 6 minus 2 is 4. That works. Negative 6 plus 3 times a negative 2 is a negative 6. So negative 6 plus a negative 6 equals negative 12. That works. So my solution to this system is -6, -2. This next example, I got x plus 3y equals 15 and 2x minus 3y equals 3. So this time, if I'm looking at this system of equations, I can see that I got two things that are the same coefficient in front. The 3y, the y's have the same coefficient, those 3 y's have the same coefficient, and they have opposite signs in front of them. This is a plus, and this is a minus. So that means I can eliminate that y right away. This variable y can be eliminated right away. So when I add these two equations, so let's do it. Let's add these two things up. So whenever I do this, I get 1x plus 2x equals a 3x. And whenever we do this, like we said, the y's eliminate, and 15 plus 3 equals 18. Then to solve for x, I'm going to divide by 3, and I get x equals 6. Now, remember I have to plug this 6 into one of these two original equations. And I'm going to do the top one again because that has a coefficient for 1 in the x. Those numbers are a little bit smaller. So I'm going to say x is 6, so I'm going to say 6 plus 3y equals 15. Now again, this is a two-stepper to solve, so I'm going to do -6, and I get 3y. 15 minus 6 is 9. 9 divided by 3 then is y equals 3. Okay, so there's my answer for y, and I got my answer for x of 6. So whenever I write this solution, it's going to be a 6, 3. Remember, x comes first, then y. And again, I can plug these in to the originals and see if it checks. So 6 plus 3 times 3 is 9. 6 plus 9 is 15. That works. 2 times 6 is 12. 3 times 3 is 9. So 12 minus 9 is 3. That works. So my solution is 6, 3. Last example here. All right. This time we got 2x plus 2y equals 8, and 5x minus 2y equals 6. And again, if we're looking at this, and I'm looking at my y's, right away I see that I have two of the same coefficient and opposite signs. I have a plus 2y and a minus 2y. So right now, I know whenever I add these two equations up, the y's are going to cancel right away. So I'm going to do that. I'm going to add these two things together. So 2x plus a 5x is a 7x. And again, the y's are eliminated. They're gone whenever I add those two things together. And 8 plus 6 equals 14. Then, to get x by itself, I'm going to do 7x equals 14 divided by 7, which means x equals 2. So there's my first part of the answer. Now I'm going to do, even though the numbers are a little bit bigger in the bottom equation, I'm going to do the bottom equation just to show you it doesn't matter which equation you plug into. I could plug into either of those things. It doesn't really matter. I've just been choosing the one with the smaller numbers because that's easier to do the calculations for. But I'll do the other one, the one with the bigger numbers, just to show you it doesn't matter which equation you pick to plug into. So I'm going to do the bottom one and say 5 times 2, because I know x is 2, minus 2y equals 6. So 5 times 2 is 10. So 10 minus a 2y equals 6. Means I got two steps now. I'm going to do minus 10 from both sides. So I got a negative 2y. 6 minus 10 is a negative 4. Divided by a negative 2. Negative 4. Divided by a negative 2. I get negative 4 divided by a negative 2 is a positive 2. So my solution is going to be 2, 2 for this problem. And again, we can check to make sure this is right and our solution's correct and works in both systems. So let's plug in 2. And for x and y, and 2 times 2 is 4, and 2 times 2 is 4, so 4 plus 4 is 8. That one works. 5 times 2 is 10. 2 times 2 is 4, so 10 minus 4 is 6. That one works. So the solution 2, 2 works. Okay, so whenever we're multiplying or adding these two equations, adding the system of equations, we're looking for two things that are the same coefficient in front and opposite signs before we start adding. Then we're going to go and do the same thing, get our x's values or y values depending on which variable eliminated, get our x's or y's, and then plug in to get the other one.